This is section 5.2 continued. We are looking at the bottom of page 7. This says the mean, expected value, variance, standard deviation of a binomial distribution, a binomial experiment with n independent trials, and probability of success P has the following. Go ahead and give that a star. Mean is equal to mu, which is equal to n times P. We have the variance here, which again we don't really use very often, and then the standard deviation, which is the square root of n times P times 1 minus P, or you can say this as the square root of n times P times Q, where Q is equal to 1 minus P like we've seen previous. Moving on to the next page. On page 8, it is very important to interpret and understand the mean and the standard deviation, so the range rule of thumb and the rare event rule for inferential statistics can be very helpful. So give the range rule of thumb, we've seen this quite often. We need to know this. Significantly low values are less than or equal to mu minus 2 sigma. Significantly high values are greater than or equal to mu plus 2 sigma, and values that are not significant are between those two. Example says between 1974 and 2011, there were 460 NFL football games decided in overtime, and 252 of them were won by the team that won the overtime coin toss. Assuming that winning the overtime coin toss does not provide an advantage, then P is equal to 0.5 and Q would be equal to 0.5. Part A, find the mean and the standard deviation for the number of wins in groups of 460. So our mean from the previous page is n times P, and our standard deviation is equal to the square root of n times P times 1 minus P. And n is equal to 460, and P is equal to 0.5. So substituting those values in, we get 230 games for the mean. For the standard deviation, we have and try that on your calculator, where it's around 2 decimal places. I get 10.72 games for our standard deviation. Part B says use the range rule of thumb, which is right up above, to find the values separating the numbers of wins that are significantly low and significantly high. So significantly low values are going to be values that are going to be smaller than mu minus 2 sigma, and significantly higher are going to be values that are greater than mu plus 2 sigma. We've calculated mu and sigma right up above, so I'm just going to go ahead and substitute those values in. And working this out, significantly low values would be values that are less than 208.6 games. And significantly high would be values that are greater than 251.4 games. Things that are not significant would be things that are in between. So significantly low and significantly high. Part C is a continuation of this that says, is the result of 252 overtime game wins in 460 significantly high? So significantly high is anything greater than 251.4 games. And this value that we have, 252, is larger. So yes, 252 is significantly high because it is greater than that cutoff, which is 251.4 games. There's another way to do this, using probabilities to determine whether results are significantly high or low. You can go ahead and calculate those probabilities, and as long as they are less than or equal to 0.5, very small, very unlikely, then we can say that it's significantly high or significantly low.